I thought I'd have something a bit different for this evening's video. Going through a box of stuff being thrown out at work. We've got a sort of like a collection of stuff that's being disposed of. We've just cleared out some old offices that haven't been used in a while, and I was rummaging through the stuff to see what there was, and I came across this old calculator. I've never seen this before. I've worked at the company quite a long time and I've never seen this before. I thought it was quite interesting, and then realised it was a nixie tube calculator, which got me a bit excited, I must admit, because I quite like all nixie tube stuff. So I thought, oh, well, I wonder if it works. So, well, let's find out. I've plugged it in. It's a Monroe 920. Apparently, I've had a quick look up on the internet. It's very similar to a Canon calculator at the time, and it just says Monroe International Division, Lytton Business Systems Incorporated, and it's a model 920, and it's a non-interference model. Apparently, it's made in Japan. It takes 13 watts, 220 volts. Okay, and it's obviously sort of an early calculator. It looks like it's been stored next to a printer, because every time I pick it up I get covered in black ink, which is a real pain. So I've got to try and clean it up a bit before I can do too much with it. But let's switch it on and see if it actually does anything. Well, I don't know if you can see that. There we go, you can see that a bit easier. It's got all the 9s, 99, so let's clear that. It looks like it actually works. Let's try it. 3.1415927. Okay, it's missed out some of the buttons. This might be the 2-digit. Clear. 3.1415927 divided by 100 times 100 equals, and it's crashed. Now it's got an arrow here. I'm not sure what that means. I don't think that means an overflow. Let's clear it. It's a good chance that the power supply caps all need replacing, but the tubes, the nixie tube, looks okay. So let's try again. 3.14 divided by 2 equals, okay, yeah, 1.57 times 2 equals 3.14. Okay, so just wondered if there's an option where you let's try plus. Got a plus? Where's our plus? Oh, because this is probably one of these calculators that doesn't have a plus button on it, because it's like an adding machine more than anything. So there's a plus equals, but it looks like it works. I think we'll take it apart and have a look. Once I've found something to clean all this muck off my hands, all this ink that it's shedding everywhere. It's a bit of a pain. I don't know where that's coming from. Give it a bit of a clean up first. Probably quite a collectible item. Not entirely sure what its age is. I would say it's probably late 60s, maybe early 70s. Hard to say really. But it's not in bad nick. So I think I'm going to sort of probably try and restore it actually, and just not going to use it, but it's certainly worth keeping because it's a nixie tube. So let me get the base off it and we'll have a look inside. Okay, this is the insides. As you can see, it's certainly shows its age. Looks like it's pretty using silicon rectifiers for the front end here, smoothing stage here, capacitors. I can't see a date code on. It's using Nichicon capacitors. I don't know what this black stuff is everywhere. I don't know if it is ink, I don't know if it's some sort of rubber decomposing. And here are the nixie tubes, and as you can see, you know, the way these things were made, they must have cost a lot of money. And it's got Canon written inside it. So it is made by Canon. Now that's interesting. So that narrows it down a bit. Let's get the nixie tubes. They're absolutely filthy. So that one, let's power it back up and just see what it looks like when it's bit better. You know, the nixie tube's all lit up. You can see that very easily. Give you a zoom in a bit. Now, I don't know what this is actually going to need, but at the moment it all looks working okay. You can see this board lower down here, in the back of the keyboard's all sort of got reed relays in, and they are the magnetic contacts from the switches. It's quite incredible. I'll give you a zoom in on that so you can see. Just zoom in here so you can see what's going on. There's obviously these switch contacts. I don't know why they're using reeds like this, but just bring it round so you can see what's going on there. You can see these reed relays here. All these reeds, and then there's a magnet switch with a lever here. When you activate the switch, it just breaks the contact on the switch. Incredible! I've never seen anything like this before in my life. So it's obviously very early sort of technology. It's TTL logic all the way through by the looks of it. 7.4, 1S series sort of stuff. You know, the sort of stuff you'd expect from probably, well, 70s, I would say, early 70s. Let's get back into view of it. But it all looks like it's working fairly well. What I need to do is go around and check the power supply. Now it looks like it's got like some sort of inverter here. There's an oscillator sort of control thing here. We've got a couple of rail supplies. Just checking to see if any of these caps are getting warm. You have to be a bit careful because there is high voltage, and the high voltage is used to power the high tension of the nixie tubes. So just make sure that they're all okay. Well, they're fairly bright, so that's quite a good start. Let's just see what voltage we got on the supply line, and then all it really means is just checking to make sure the caps are good in it. Aren't going to dry up, or we can check those. But let's have a look, see what we've got. So we've got, looks like an AC supply in here, maybe. No, this is the AC supply to the left. So let's you interview a bit better. I just want to check, really, make sure that this power supply is not going to sort of just let go as soon as it's been on for a while. So we've got apparently plus 220 volt DC here. I'm going to touch that, and that's showing. That's showing 170 volts. So that could be capacitors need replacing. Yeah, 170 volts. That's a bit low. We've got a minus 5, which is showing minus 5.6. That's okay. That's an earth. We've got a plus 5.3 here. Plus 5.5 is good. So it looks like possibly we've got a high frequency multiplier circuit that produces the high voltage for the nixie tubes, and that's probably why they're a little bit dim. So what we could do is try. What voltage we've got across this capacitor. There's a 10 volt cap. There's a 10 volt cap. So that's 10 volts. There's the high voltage stuff here. So let's have a look, see what we've got across these Nuticons. We've got 230 volts there. We've got 8 volts on this one. Oh, that's actually a 16 volt capacitor. So this is also the high voltage side. Try and find a circuit, I think, to see if we can work out what does this. Now this is obviously the like a multiplier, and I'll have a quick tweak of this capacitor and see if we can know what effect it has on the high tension. Oh, it makes it a bit. Well, it's crashed it, so that's probably the main oscillator. So I probably don't want to piss about that too much. It's a bit of a sort of shot in the dark. I thought might be that was high tension. Oh, it's a pot or what it is. Let's just check the HT. Don't know, it might be the LV section. We don't know overvolt the thing. So let's just check it at 5.5 again. Okay, 5.5 is now 3.6. So let's readjust that. I thought it was a trimming capacitor, but it's not. It's a. This is the supply line. So we'll go 5.3 here. It actually looks like it's barely managing to do 5.3, but it looks like it's all working. There's no sign of anything getting warm. I'm a bit concerned about that high voltage capacitor because it's probably leaky, and I might need to replace that. But what I'll leave it do is I'll leave it on for a while and see if the HT comes up slightly. So we've got now 178 volts. So yeah, about 178 volts, about 170 volts. So it might be coming up slightly. So I'll put it back together once it's all sorted out, but there's not a lot to see really. I mean, it's all germanium transistors down here. I'm trying to find a date code. Could it be 61, 1961? It's quite feasible. Can't see anything on the capacitors. I'm not going to touch this one whilst it's on because it's got high voltage DC on it. But, interesting old piece of kit. And I'll definitely one to sort of keep up and put in the museum of antique junk really. Anyway, thanks for watching, and more to come. It's a bit of a quirky layout and quirky setup. It isn't actually TTL, it's diode transistor logic, which is the very first form of logic gates invented. It's great actually. It's really funky thing. The displays come up quite nicely. The power supply sort of recovered slightly. There's one cap that's a bit dried up, but the rest of them are okay, and it seems to be working fine. As you see, it hasn't got a plus or minus key. The plus key is the equal key, and the minus key is the red equal key. Strange, I know. This switch here shifts to how many decimal places it will work to. It's working on 6 decimal places at the moment. So it's quite straightforward if you just want to add up numbers. So 36, 22, 99, 12. It's just an adding machine really. 85. There you go. 254. And then you want to take up minus 254, and I'll give you an answer of 0. It's got a constant function as well, so I think you can do 36 plus, and if you put the constant on, so if you go clear 36, I don't know, it doesn't work. Well, I thought it was a constant like it was in the old calculators where you press the plus twice and it gives us sort of like a constant, so you can go 36 and just use it as an adding machine. Might be doing something wrong there. There's your divide key down here, and there's your multiply key here. This is clear the whole memory, I think, and this is clear one step back as far as I can work out. It's also got apparently what they call an acoustic memory. I don't know if it's literally acoustic, but it suggests that the memory system is like a diode acoustic memory or something. Don't really understand it, but it is a copy of a Canon, or it is a Canon basically, with just this Monroe name stamped on it. It's got a bit on the internet about them, but it's nice. I'm glad I rescued it from the tip, like I do rescue everything, because as you see the display is quite nice and sharp, and it's a bit of history. Thanks for watching.